We're going to be looking at combinations versus permutations. And I have our question set up here. My friend Dave here has 4 pets. He has a cat, a dog, a bird, and a fish. And he loves to take pictures. And he wants to know how many different ways he can take pictures of all of his pets. Now this begs the question, is Dave looking for a combination type equation or a permutation type equation? And we should really talk about the differences between the two of them. First of all, here's our formula for a combination, and here's our formula for a permutation. N being the total number of pets. Well, let's figure that out. How many pets are there? Well, clearly he's got 4 pets, right? So his N is going to be equal to the value of 4. Okay, so we know that we'll plug that in. We would plug the value 4 in here. And depending on how many pets he wants in each picture, that's our R. If he only wants 1 pet, then our R would be equal to 1. If he wants all 4 pets in the picture, then R would be equal to 4. And that essentially categorizes all of the variables in the equations. But you'll notice there's a difference between the two equations, and the main one being the R factorial on the bottom of a combination. And the point of that is to get rid of redundancies, okay? So in other words, if we were counting dogs and cats in our combination, what we're saying is if I'm taking a picture of the cat and the dog, then I don't want to count also a picture of the dog and the cat, right? But if their order is important, then a permutation here includes those redundancies, and you'll get a much larger number. So let's kind of go through this process here. Let's scroll down. So what we have here, and I'm just going to split the two, is let's talk about our very first one. Let's say he wants the 4 pets in a combination, and he wants to know how many ways he can take a picture of one of them. Well, that really leaves you with just cat, dog, bird, and fish, right? There's really only 4 ways you can do this. A cat, you can take a picture of the cat, the dog, the bird, or the fish. And if you plug that into this equation here, you'll notice that you end up with 4 factorial over 4 subtract 1 factorial times 1 factorial. Well, a factorial is that value times each whole number before it. So 4 times 3 times 2, all the way down to the number 1. Okay, so that's what 4 factorial is. So this ends up being 4 factorial over 3 factorial times 1 factorial. Well, the 1 factorial, 1 times 1 is 1. 3 factorial is 3 times 2 times 1, which is 6. Okay, and I'm just going to show you a quick shortcut for minimizing these. This 4 gets 4 by 3 by 2 by 1. So I'm kind of simplifying this over 3 by 2 by 1. Okay, technically times that 1 factorial, but that's times 1 again. It won't do anything. And think of these as all creating 1 values or canceling out. And essentially, we're just left with the number 4. Now, you might have a calculator that does all of that for us, but that's exactly what we got. We got 4 pictures. And if you were to do the permutation this way, 4p1, okay, you end up with 4 factorial over 4 minus 1 factorial, and it ends up being the exact same thing your value is 4. There's really no other way to go about doing that. Now this is where it gets a little trickier. Let's do our next step here. Okay, our next one, let's say Dave wants to have 2 animals in the picture, so he wants a 4 combination 2. He wants to know how many different ways he can do it, and there's actually quite a few. So I'm going to list them and then quickly use the formula to show you the differences here. So in this one, actually let's do the formula and then list them all. We have 4 factorial over 4 subtract 2, okay, factorial times 2 factorial. This is going to be a little different. 4 factorial, 4 times 3 is 12, times 2 is 24, okay, over 2 factorial, which is 2, and 2 factorial, which is 2 again, over 4. So 24 divided by 4 is 6, okay? And in our permutation, if you notice 4 permutation 2, we get 4 factorial over 4 subtract 2 factorial. Okay, and this becomes 24 over just the value of 2, which gives us 12. So we get way more permutations than combinations. And let's talk about that idea. Okay, so if you recall, all the way at the top, we had a cat, a dog, a bird, and a fish. So We can have the cat with the dog, we can have the cat with the fish, and we can have the cat with the bird. Probably eat each other, but that doesn't matter. That technically still works. We can have the dog with the fish, and we can have the dog with the bird, and we've already counted the dog with the cat. That's the idea of a combination. It's already happening here, so we don't include that one. We can then have the bird with the fish, right? You could also have the bird with the dog and the bird with the cat, but again, those have already been counted. We did the cat and the bird and the dog. We did that there. And then you could tactically count the fish, bird, okay? Fish, cat, fish, dog. But all of those have been counted. The bird and the fish is just a different order, the cat and the fish, and the dog and the fish. Okay, so this extra factorial 2 essentially cuts your info in half. Okay, it's getting rid of any of the redundancies, which we just saw there. There was, if we count for our combination, 1, 2, 3, 4, 5, 6, exactly what we have. But in total, we have 3 by 4, which gives us our 12. So all of these would be our permutation, but our combination, that extra r there, gets rid of our values. Okay, so that works out great there. Let's continue this out, because technically all of these values here, whoops, that's not what I want to do. Technically, each of these is just one set of the combinations we can do. I'm having a lot of trouble moving this. Okay, I'm not going to move that. Let's just continue on here. All right. So let's do 4 with the, using 3 pets in a picture. Okay, and if we quickly use the formula, we'll get an idea that this becomes 4, subtract 3, and then that 3 gives us getting rid of any redundancies. And for our permutation, 3, well, not C, 3 is equal to 4, and then 4 subtract 3. Value. If you end up doing this, this becomes 24 over 1, which is the value of 24. This one here becomes 24 over 3 times 2 is 6, which gives us a value of 4 different options. And finally, our very last one, put a line in, a line here, 4 combinations of 4. Well, there's really only one way to do this if there's no redundancies, right? You have 4 factorial over 4 minus 4, which will give you 0, but you still have this one here, and 4 divided 4 factorial is 1, while in this case here, we'll end up with 4 permutation 4. I know this is becoming a little redundant here. 4 subtract 4, same idea as before, we get, again, 24. So if we don't care about redundancies, I know there's a lot of page to look at, for our permutations, we'd add up the values of 4, 12, 24, and 24, okay? And that's going to give us, what, 48, 50, 64, I believe. So a total number in permutations of 64 different ways, if you don't care if the dog's on, or if you do care if the dog's on the left and then the dog's on the right. But if you're just doing dogs and cats and photos, so just the combinations, the total number of combinations we would add is 4, 6, 4, and 1, which means we would get combinations total of 5, 11, 15. Now, with that being said, you'll notice these grow much quicker. I have 2 friends, we'll call them Else and Dave, and they asked me this question. Is this statement true? They're at a Blue Jay game, and they said that they went to get, I guess, hot dogs, and there's 15 fresh toppings, and they say there's over 6,000 combinations. I quickly took an Excel sheet out. Okay. If you notice, here's our 4 combinations. These are our numbers of 4. Remember, we got 15 and 64. For our combinations, if we were to add up every set of combinations, there are 32,767. So they clearly could have said there are many more than 6,000. And if they're talking about permutations, they don't even care what order things are in. We're looking at what here? This is 100, million, billion, trillion. There are over 3.5 trillion options. If you actually don't care if the ketchup comes first, or sorry, you do care if ketchup comes first, and then in the next one we want mustard to come first, with everything else being the exact same. Okay, so there you have it.